As a videographer, generative fill tools have slowly started to become a major part of my editing workflow. I first discovered generated fill layers within Adobe After Effects while searching for new visual effects to enhance my short-form content. Since then, I've used them regularly for a variety of effects, including clean slates and object removals. The tools often produce convincing results. However, after deeper consideration, I realized I didn't fully understand what was actually happening behind the workflow, or when certain generative methods were more effective than others. These gaps in understanding quickly became important for my editing process because inconsistencies in the final results of effects often led to time delays, longer workflows, slower turnover, and more burnout. So in this video, I will be comparing and analyzing the role of AI generative tools within object removal and frame reconstruction workflows using Adobe After Effects and Photoshop. More specifically, I wanted to understand how AI generative tools compare against more traditional reconstructive methods like clone stamp and content-aware fill, both in terms of editing efficiency and the final visual quality. Before comparing the workflows themselves, it's important to understand the difference between AI generative tools and more traditional algorithmic editing tools, because while they can produce similar results, they actually function very differently behind the scenes. Inside After Effects, generated fill layers are powered by Adobe Sensei, Adobe's machine learning and computational analysis framework. When trying to complete an object removal, instead of having to manually rebuild missing areas frame by frame, After Effects allows us to analyze surrounding footage and then synthesize replacement pixels using information pulled from nearby frames. The software basically studies the environment around the masked object we are trying to remove, and then predicts what should exist behind it throughout the sequence. Depending on the footage you're working with, After Effects can prioritize different reconstruction strategies using settings like object, surface, and edge blend. These will be important to consider later on in the video. For more complex video footage, reference frames can also be a vital tool for object removals and will help demonstrate the role of AI in frame reconstructions as they are created and edited in Photoshop. A reference frame is essentially a corrected frame that gives After Effects a cleaner example of what the reconstruction should look like. These reference frames are initiated in After Effects, edited in Photoshop, and then linked back into After Effects where the final fill layer is generated across the sequence. The important distinction here is how these reference frames are actually created. Tools within Photoshop, such as the clone stamp, are fully manual reconstruction methods. The editor directly samples nearby pixels and rebuilds the missing area by hand. Nothing new is being generated. The software is simply copying and blending existing information based entirely on human input. Content-aware fill tools introduce a more automated algorithmic approach. Instead of manually painting over the object, Photoshop analyzes nearby textures and procedurally predicts how the missing area should be reconstructed using surrounding visual information. While this process is automated, it is not considered true generative AI because it primarily relies on nearby sampled data instead of synthesizing entirely new imagery. Content-aware fill is present in both After Effects and Photoshop, so I will be showcasing those distinctions in my analysis as well. True generative fill tools, however, use Adobe Firefly, Adobe's AI image generation model. Unlike content-aware fill, AI generative fill attempts to synthesize entirely new image content based on visual context and pattern recognition. Rather than simply extending nearby textures, the AI predicts what should realistically exist within the missing area and generates new details automatically. This distinction is the foundation for my testing process because I wanted to compare how AI generative reconstruction differs from traditional algorithmic and manual workflows in terms of speed, consistency, creative control, and overall effectiveness. Who does it best? Now, with some of the technical explanations out of the way, let's get into the different methods I chose to analyze. For the first case study, I wanted to begin with a relatively controlled environment. For this, I chose an original static shot of an alpine lake. The goal of this test was to remove the bag and clothing located in the bottom left corner of the frame near the shoreline while maintaining a believable reconstruction of the surrounding rocks, water, and textures. To complete this accurately, the surface fill method was selected in the After Effects Content Aware module. To analyze how different reconstruction methods handled this task, I completed 4 separate object removal tests, each using a different fill generation workflow. The first test used a pre-composed generated fill layer completed entirely within After Effects using Adobe Sensei's automated reconstruction system. The second test used a manually reconstructed reference frame created in Photoshop via the clone stamp tool. The third test used a content-aware fill reference frame generated within Photoshop using Adobe's procedural reconstruction tools. And finally, the fourth test used an AI Generative Fill reference frame created in Photoshop using Firefly. In order to keep the comparison as consistent as possible, each test was completed using the same source footage, masking process, and reconstruction area settings within After Effects. Each workflow was also timed from start to finish in order to compare not only the final visual quality of each result, but also the efficiency and practicality of each method within a real editing workflow. Here are the final results. After seeing the results, it's clear that each method introduced some level of visual inconsistency. Across nearly every test, there were distorted pixels, frame blending issues, and temporal artifacts where certain textures failed to properly move with the original footage. The weakest result overall came from the clone stamp reference frame. While this workflow offered the most direct control during the Photoshop stage, it also took the longest amount of time to complete and ultimately produced the least convincing final reconstruction once processed back through After Effects. The shoreline textures struggled to blend naturally across the moving water, resulting in noticeable inconsistencies throughout the shot. The pre-composed fill layer completed the effect much faster than the manual process. However, the automated reconstruction often replaced parts of the shoreline with dormant water pixels that failed to move naturally with the footage, making the final result feel less realistic over time. The content-aware fill reference frame workflow produced some cleaner shoreline textures and helped reduce many of the gaps and artifacts present in the previous methods. However, it did take longer to complete than the pre-composed fill method. The strongest overall result came from the AI Generative Fill reference frame workflow. Not only was this method the fastest to complete, but it also produced the most realistic reconstruction. Compared to the other workflows, the AI generated reference frames minimized dormant water pixels, preserved more believable shoreline textures, and blended more naturally with the original footage throughout the sequence. Overall, the static shot revealed a clear trend. As the reconstruction methods became more context-aware and AI-assisted, both workflow efficiency and final visual quality generally improved. However, I wanted to see what would happen if things got a little more complex. Now that the reconstruction methods have been tested on a static environment, I wanted to see how they perform under much more difficult conditions, a moving object within a constantly changing frame. For the second case study, I used original slow-motion footage of a basketball flying through the air inside a gymnasium. Unlike the previous shoreline shot, this sequence introduced motion blur, changing perspectives, shifting lighting, and a far more complex background, making consistent reconstruction significantly more difficult. The goal of this case study was to remove the basketball from the shot while maintaining believable reconstruction across the moving sequence. After manually masking and tracking the ball throughout the shot in each test, I tried 3 different reconstruction methods. First, a pre-composed generated fill layer completed entirely within After Effects. Second, several content-aware fill reference frames created in Photoshop. Side note here, because of the complexity of the gymnasium background and the changing motion throughout the sequence, multiple reference frames were needed to give After Effects more visual information to work during the reconstruction process. The third test followed the same reference frame workflow, but instead used AI Generative Fill inside Photoshop, powered by Adobe Firefly, to reconstruct the missing areas before generating the final fill layer back inside After Effects. Again, this test needed multiple reference frames to provide extra visual information. keep the comparison consistent, all 3 tests follow the same masking, tracking, and editing processes. In addition, the generated fill layer settings within After Effects were kept consistent across each workflow, with the fill method set specifically to object, in this case, in order to optimize reconstruction for moving objects and changing environments. Here are the final results. The results from the moving shot tests ended up being much more surprising than the static shot comparisons. Across all 3 workflows, the object removal results were actually very convincing overall. Even with the added complexity of camera movement, motion blur, and a constantly changing gymnasium background, each method successfully removed the basketball in a believable way. In fact, if you were not specifically looking for reconstruction artifacts, it would be difficult to tell that a basketball had originally existed in the shot at all. That being said, small imperfections were still present throughout each workflow. Certain frames introduced slight distortion, muddled textures, or brief temporal inconsistencies, where portions of the background struggled to reconstruct perfectly around the moving object. However, unlike the static shot tests, the strongest result this time did not come from AI Generative Fill. The pre-composed generative fill layer, completed entirely within After Effects, actually produced the cleanest overall reconstruction, while also finishing in the shortest amount of time. Compared to the reference frame workflows, the pre-composed method completed roughly 4 minutes faster than the content-aware fill reference frame process, and over 5 minutes faster than the AI Generative Fill workflow. This result was especially surprising because the AI-generated workflow had several additional reference frames to work with, which should have given After Effects more visual information to build from and theoretically led to a better result. Despite this advantage, the AI-generated reconstruction still introduced more noticeable artifacts and inconsistencies than the simpler pre-composed workflow, and was even bested by the content-aware fill reference frame workflow. For this particular type of motion-based object removal, the automated content-aware reconstruction inside After Effects appeared better optimized for handling fast-moving subjects and changing environments than the AI-generated reference frame approach. Personally, this completely changed the way I think about using AI-generative reference frames within my own editing workflow. Going into this project, I expected the AI-assisted workflows to consistently outperform the traditional methods. Instead, the moving shot test showed that AI-generated reconstruction is not automatically the best solution simply because it is more advanced technologically. In some cases, introducing AI into the workflow actually added additional time and complexity without improving the final result. This is crucial for time efficiency, turnover, and avoiding burnout in the editing process. Overall, the findings from both case studies revealed that AI generative tools are most effective when dealing with controlled environments and repetitive cleanup tasks, especially situations where believable texture reconstruction is more important than motion consistency. However, when dealing with more complex motion-based footage, traditional algorithmic reconstruction methods, like the pre-composed generated fill layers inside After Effects, often proved to be faster, more stable, and more practical within a real editing workflow. More importantly, this project shifted my understanding of AI within creative software altogether. Rather than replacing traditional workflows, AI generative tools seem to function best as supplemental tools, accelerating certain parts of the editing process while still requiring human judgment, oversight, and decision-making. In the end, the best workflow was not determined by which method used the most AI. It depended entirely on the type of footage being reconstructed, the level of consistency required, and the balance between efficiency and creative control. For me, that became the biggest takeaway from this entire process, and is going to drastically change how I approach the editing process in the future. Thank you for watching.